Greetings, 7th grade. Today we're talking about multiplication and division equations. Let me make sure that. Alright, talking to the headset. Great. So we've already talked about addition and subtraction equations, getting back used to our process for equation solving, and also dealing with integers, negative numbers now while we're going through. So let's look at this new development with multiplication and division equations involving integers. So again, you do not need to draw this, but I am going to try and give you a picture about why does our equation solving process make sense, what might a good physical representation or visual representation of this equation look like. Now in this case, we do not have algebra tiles with our x boxes. Again, these x boxes we think of as hiding a value. We don't know how many tiles are in there. We don't know how much these are worth. All we know is we have 3 x boxes. So instead of actually writing x plus 3, we have 3 times x. We have 3 x's, or 3 of x, or 3x. And again, on the right side, we have -6, so that's easy enough to count. 6 negatives. Now, how can we solve this? What we're trying to do, as always, is to figure out what is one of these variables worth. What is the value of x? So to do that, we can't just get rid of the algebra tiles that are with it because we only have x's. And again, since we don't know what they're worth, we can't just add or subtract the same value on the other side. But hopefully what you're seeing, what we can do is if we get more creative, we can say, listen, I know that this is balanced right now. So I know that 3 x boxes balance with 6 negative boxes. Well, I don't know how much I'm taking off when I take off an x box, but I do know that I'm taking off 1/3 of the left-hand side. So if I can take off 1/3 of the right-hand side, it should stay balanced. And if I take off another third, or what is now half of the left-hand side, I can take off half or 1/3 of what began on the right-hand side. And now we can see that we're balanced again, and it's still balanced. And in this case, x must be equal to 2 negatives, or -2. Now what does that look like when we write it out? Well, what we had here is we had 3 groups, and what we did is we split the groups up. So this kind of makes sense that we use inverse operations. If we have multiplication or 3 groups of x, we can divide by 3. And if we divide by 3 on the left-hand side, and we leave just 1/3 of what was there, then we can divide by 3 and leave what is 1/3 on the right-hand side. Again, these we're doing the same to the left what we did to the right. And we'll be left with -6, or 6 negative boxes divided into 3 groups. That left us with 2 negative boxes. Negative divided by a positive is negative, and this again gives you a visual representation of why that rule makes sense. So you don't need to have this drawn just yet. I am going to have you draw a different set of scales, but for that one, hopefully that one made sense to you, why we divide to undo multiplication, or what multiplication of x boxes looks like. We have multiple x boxes. Again, I'm going to have you take down notes, and a lot of them are the same. Please write them again. I will be checking this. Step 1, draw the scales of justice. Step number 2, I'm going to try and do my best to mimic, I think Jay said a good one. We need to find the variable, or find the variable. And step number 3 is to isolate the variable by undoing what's been done. And in this case, multiplication undoes division and vice versa. So these are called inverse operations. We just saw in that example why it is that division undoes multiplication. We're going to see the opposite, why the opposite is true as well in a second. But the last note I really want you to take down and make sure you understand is that instead of dividing, you can always multiply by the reciprocal. So I want to see what that looks like. Well, if we're multiplying and we say 3x, let's say 3x is equal to 9. And in this case, to undo this multiplication, we can divide. Now, we could divide both sides by 3, and that would be easy enough. But another way we could do this, and it's easier especially if you have something like a fraction. This will be useful later. I want you to pick it up now. Is that another way we could get this 3 to cancel is we can multiply by 1/3. We could say, well, I know if you multiply by 3, but then you multiply by 1/3, you're going to end up with the same number you started with. Those undo each other. They cancel each other out. A good way to see this is if you multiply top times top and bottom times bottom, these will cancel out, and we're just left with 1x. So x in this case would be equal to, again, if we multiplied the left by the reciprocal, we have to multiply the right by the reciprocal. Multiply both sides by the reciprocal. We'll be left with x is equal to, and in this case, if you remember your multiplication of fractions, top times top is 3, bottom times bottom is 10. So we can also multiply by the reciprocal to undo things, and I'm going to ask you to remember that for some examples later. So maybe rewatch that if it doesn't make sense, or just know that a reciprocal is when you flip the numerator and denominator. So it kind of goes along with same, change, flip. Instead of dividing by a fraction, you can multiply by the reciprocal, and that works for everything, not just fractions, but even if you make whole numbers into fractions by putting them over 1. Just saying a lot of math stuff. I hope it makes sense. All right, this is an example that I am going to have you start with. I do want you to draw this not just numerically in the equation form, but also draw the scales for me. In this case, we don't have a full x box. It looks like we have 1/3 of an x box. So 1/3 of an x box could be thought of as an x box divided by 3, and we'll just have what's left when you divide it by 3. And what is it equal to? Well, it's equal to 4 negatives, or -4. Now, this is going to be a demonstration of why does multiplication undo division. Well, let's think of it this way. If we want to find out what a full x box is worth, I can start by just doubling what's on the left-hand side. I don't know what's in there, but if I know that if I have not just 1/3 but 2/3 of an x box, if I double what's on the left, I can double what's on the right. And they should still be balanced. And so this would be another balanced portion. And then, of course, to find out what the full x box is worth, I need to add another set of what we originally started with. And if I do that, then we'll be left with a full x box on the left. We multiplied just 1/3 of it. We multiplied and said, what if we had 3/3, or we multiplied by 3? We multiplied the right-hand side by 3 as well. So as long as we were just reproducing or adding the same amount over and over and stacking it, the same thing to both sides, as long as we multiply both values, then we should stay balanced. So in this case, you could say that we multiplied the left-hand side by 3, and we multiplied the right-hand side by 3. On the left hand, that's nice, because if you multiply a number times 3 and divide by 3, so if you, for example, if you take your age, multiply by 3, I'll give you a minute. For me, it's like 1,000. And then if you divide it by 3, that same number you just got, you'll get back to your age no matter what, because those inverse operations undo each other. So now we're just left with x being equal to -4 times 3. We saw y in -4 times a +3. 3 positive groups of -4, or 3 true groups, real groups, not the opposite of 3 groups, but 3 groups of -4 would leave us with -12. So make sure you have that drawn out, not just numerically or not just visually with the scales, but both, please. And we're going to move on to some regular examples. So here we go. Number 2 says -16p equals -496. So in this case, we're going to follow the same steps as always. I'm going to draw the scales of justice. We're going to divide both sides by -16, and as long as I'm dividing both sides into the same number of groups and removing them, then we should stay balanced. Again, those inverse operations cancel out. It was equal, or it was the same. It was kept us balanced when we divided both sides by 16. Now I know a negative divided by a negative are integer rules for multiplication and division. Say the signs are the same. That'll be a positive answer. And 496 divided by 16. Let's just figure this out really quickly. 16 goes into 49 3 times. 3 times 6 is 18. Carry a 1. 3 times 1 is 3 plus 1 is 4. Subtract and we get 16. Okay, 16 goes into 16 one time. So this would be 31. And it comes out evenly. How nice. So this is a positive 31. Now here we have, for example, number 3. 1/5 of a number is equal to 3. So the easiest part of that is saying equal to 3. Now 1/5 of a number, let's use the number h, which is a number because it's a variable in this case. 1/5 of a number, which we don't know yet, so we'll use a variable h. 1/5 is equal to 3. Now we could either think of this as 1/5 of, so 1/5 times h, Or we could say 1/5 of a number. Well, to find out what just a fifth of it, you could just divide it into 5 parts, and we'll find out what one of those parts is. I'm going to say if you divide by 5, you just multiply both sides by 5 to undo the division. I want to show you what it looks like if we think 1/5 of a number, 1/5 times a number. Now in this case we have multiplication. We could undo that by dividing, divide both sides by 1/5. But this is what I was talking about earlier. We could also cancel this by, think about what I'm about to say, please. You could also multiply by the reciprocal. As long as you do it to both sides, then we'll stay balanced. The reciprocal of 1/5, you just flip it. It's not the opposite. Don't change the sign. We just flip the numerator and denominator. These will cancel. We'll just be left with 1h, or just h, and that's equal to 3 times 5 over 1 would just be 15. So again, this is another example of multiplying by the reciprocal, and hopefully that makes sense to you. If not, ask me, please. Now make sure you have these notes down. As always, I'm going to leave you with some practice problems to try out on your own. You're free to do them in the way that makes sense to you, but please follow that 3-step process of drawing the scales of justice, locating the variable, and isolating the variable by undoing what's been done. The practice problems: k divided by 51 equals -11. So what is k? Solve for k. And 2, 1/3 of h is -9. Find h. So again, you can write that as division or multiplication, whichever makes more sense to you. Whether you want to do with a fraction or just division, it's up to you. I will see you later.